guns in the shadows of the night.
Today we're going to talk about making items on a CNC mill in bulk. And I'll be honest, this is probably going to be one of my more boring videos in terms of like visualizations, because a lot of it is going to be sitting right here and talking. A little bit of milling will be shown, but most of it will be right here. However, this might be the single most important video I've made so far in terms of level setting and educational content for people looking to get into CNC milling. And that's because on the surface, it's about creating items in bulk. But what it really is below that surface is how to be profitable doing CNC stuff. As always, a big thank you to Speed Tiger for sponsoring my CNC content. And full disclosure, Tosa Tools did give me an amazing deal on the big fixture plate shown in this video, but I did spend money on it, and I would have bought one regardless, as the quality of life improvements it brings are undeniable. Don't forget, failing to like and subscribe is a leading cause of depression. I'm going to do this using two methods. We are going to talk about some concepts in generalities, and then I'm going to apply it to the parts you see here, which are what I used to make these magwells in a very small level of bulk, but still bulk. In order to understand why these concepts are so important, we need to first understand why we do CNC. And that's because when the machine is running, it's doing work for us. That is time that we can be off doing something else. So it is a force multiplier in terms of productivity. However, a CNC does not just magically run itself. There are things that we have to do throughout the process. Every time that we have to manually intervene in that process, that is a new place where we introduce inefficiencies. I'm going to point out some of the largest areas where we lose efficiencies because a human has to manually intervene with the CNCing process. The first one is changing tools. The bottom of this magwell requires two tools in order to finish the process. It requires a 1/4 inch straight end mill to do most of the hogging out and shaping, and then it requires a 1/4 inch ball nose end mill to do the ramped inside as well as these curved corners here in the little grip area. So by definition, I have to come in and change that tool manually if I don't have an automatic tool changer. We'll get to that in a little bit. The second big place that eats a lot of time and efficiency out of our process is setups. So anytime I have to remove a vise and add another vise of a different type, or attach a jig to the table, or tram something up on my table, that's going to be another highly inefficient spot. If you ask most machinists what is the biggest kill in terms of time and efficiency, it's going to be the setup. So any way that we can drastically reduce our setup times means money, means the machine is running longer. The last inefficiency that I really want to point out isn't actually us doing something, it's actually us not doing something. If you have a time frame between two manual interventions that happens to be small, let's say 5 minutes, there's very little you can go off, walk away and do in a 5-minute time frame that's going to be productive. And so this last one is really how long we can stretch between manual interventions and how that affects our productivity and efficiency. All right, let's tackle each of those things individually, and we're actually going to start with that last one, that interval between manual interventions. Let's take a hypothetical situation of milling the bottom of this magwell that we already know takes 2 tools. Let's just hypothesize, I don't remember the actual numbers, but let's hypothesize that the 1/4 inch flat square end mill takes 3 minutes to run per magwell, and then the ball nose end mill takes 7 minutes to run per magwell. If I have one of these, I have a soft jaw that spreads out and clamps it onto the table. If I have one of those on my table and no automatic tool changer. That means I'm going to put the 1/4" square end mill in. It's going to run for 3 minutes, and I promise you, there's nothing I can go do that's productive in 3 minutes. So I'm going to sit there and watch it run, and then I'm going to pull it out, and then I'm going to put in the 1/4" ball nose end mill. 7 minutes, maybe I could go do something, but it's not going to be something super productive. It's going to be something piddly, and I will run out of those things pretty quick. So 7 minutes, I'm probably going to sit there and wait for it too. So I'm not gaining much efficiency out of that process. 3 minutes, 7 minutes. However, let's say that I create this jig. And this jig, instead of having a single vise that spreads out and holds from the inside this magwell, I can actually fit 6 of these magwells at a time, pre-milled obviously. And then we'll talk about this in a little more detail in a bit, but I have a spreading clamp that goes in there that spreads out and holds it. So instead of just running 1 of these, I can set this on my table and run 6 and walk away. Even without an automatic tool changer, if I've got 6, when I run that 1/4" square end mill, that's 6 times 3, that's 18 minutes for that 1/4" square end mill that it's gonna run. I can now walk away for almost 20 minutes. I can actually get something else done in that 20 minutes. And then let's talk about the 7 minutes that we estimated it takes that ball end mill to run this complex path. 7 times 6, I can now walk away for 42 minutes before I have to come back and manually intervene. These start to become numbers where I can actually take advantage of the CNC and the automation it provides and the force multiplier that is for my productivity. Now let's imagine that same 6-piece scenario where I do have an automatic tool changer. That means it'll run both tools without me having to manually intervene. That's 18 plus 42 minutes. That's an entire hour that I can now walk away from the machine and do something else. This is a very small jig because I only was making 50 of these. I didn't want to spend a ton of money on a giant sheet of aluminum where I could fit, say, 30 of these on my machine table at a time. But if you were doing large scale production, absolutely, that would be worth it. So imagine what those numbers look like if I'm running 30 magwells at a time. You can walk away for hours, even if you don't have an automatic tool changer. You can press run and come back a couple hours later, and you've got massive efficiency gains. The other thing to keep in mind though is when I said this is a small fixture plate that holds 6, this is a small fixture plate for my machine, my Tormach 770. I could go bigger, but that is obviously going to be dependent on how much space you have on your machine in terms of X, Y, and Z travel. So for guys that are just getting into CNC, I see a lot of them looking at machines and they look at the XYZ travel, they think about the stuff that they're gonna try and build, and they go, what I'm trying to build fits in the XYZ envelope, therefore this is a good CNC machine for me. But they're not thinking that, well, maybe only 1 of them or 2 of that object fits within the envelope. So they're about to buy a machine that if they're just doing prototype work, like mostly what I do, that's totally fine. But if they're interested in making money using that machine, all of a sudden they're about to purchase a machine that doesn't allow them to take advantage of bulk processing. Your machine has to be large enough to take several of the objects you're trying to build on the plate, or else there's not going to be room to make money. But again, if you're just into prototypes, who cares? Let's talk about the second way that manual intervention can be reduced. And that's going to be our setup times. There's 2 drastic ways that we can reduce setup times. One of them is through these fixture plates. This is a custom one that I built. I just zipped around, cut out a negative of this shape, and then added 0.02 of clearance so it actually kind of fits but still snaps on pretty tight. And then there is this, expansion clamp. We have to have an expansive type of jaw here because I don't have square sides on this particular piece. These are 3D printed, but if I was doing this professionally and like doing real production runs, I would make them out of like brass or aluminum. But basically when you clamp down on this, it spreads out and that sits here. And so it spreads out against these sides to actually, that's my holding mechanism. I can very quickly set up all 6 of these. Whereas if I had to say, do this one by one on a vise, put one in, tighten it, set up my work offsets, run it, that is a lot of time that I'm investing per piece. The way that this works is I can clamp it down to the table, I can tram it along my nice edge once, I can find this corner, which I've left information on the jig as to where that corner is in relationship to a known part of one of the models. So the center point here. And then I've just repeated that using a pattern in Fusion 360 to just repeat it 6 times. So this is a very quick setup. It's one, tram, lock down, find one edge, and go. And then when I replace all 6, I don't actually have to do any tramming. I don't have to do any work coordinate finding, because my work coordinate is based off the jig, not the piece. So every time I replace all the pieces, I don't have to do anything except literally replace them. I'm not doing any of that setup work again. So that is a great way that fixture plates or jigs can add efficiencies and reduce your manual intervention. It speeds up the time, the cycle between each run. I have a cheat code here though. These holes make it so that I don't even have to tram this. These 3 indexing holes correspond to holes on my Tosa Tools fixture plate. They're at known locations. So I literally take this, I plop it down on the table, I use those holes to positively index it, I bolt it down, and I'm already trammed. So now I've even removed the tramming with my dial indicator out of the equation. If I know which holes I'm using, and I use those every single time, so like 4th hole over from the left, 3rd hole down from the top kind of thing, I can set up a work offset in my machine's memory, and I can just keep using that. So I don't even ever have to find this corner except the first time if I didn't want to. If I use those same holes again, I can just walk up to the machine, plop it down those same holes, and start running, because the machine has saved that work offset and I can just keep going. The other thing to keep in mind is nothing would stop me from making 2 of these. Why would that help reduce manual intervention? Because I could be running one with 6 of these while I'm filling up another one with 6 more ready to go for the next round. And because I've got these positive indexing holes from my Tosa fixture plate, when it's finished running the first set of 6, all I do is pop these screws out and I throw the next one on and I hit go. Because remember, these indexing pins make it so that these jigs would fit back in the exact same place every single dang time. So I can just, that takes me 30 seconds to pop 3 screws out, pull, put a new one, pop 3 screws back in. Massive efficiency gains from not just the fixture plate in that case, but also how the fixture plate interacts with my machine through the Tosa Tools plate as well. So that is a game changer in terms of efficiency there. Because remember, if you ask most machinists what they spend the most time on, it's setup. And these 2 things just allowed us to almost reduce our setup time to 0. And any setup time we are doing on that second plate, remember, that's now work that we can do off to the side while we are running the first 6. So that first point that we talked about, where the longer I can make the machine run in between manual interventions gives me time to do stuff elsewhere. This is what I could be doing elsewhere. I could be setting up the next run so that it's just ready to plop on the second the first run is done. This is how you make money. And now let's go back to the last way that we can reduce manual interventions. We already learned a little bit about why it's important to reduce the time we have to interact with the machine to do tool changes, and how having an automatic tool changer can help us in that space. And of course, that is because it allows longer intervals between when we have to interact with the machine. We've talked about that ad nauseum. But I want to specifically talk about this item because there are ways that you can reduce your time spent doing tool changes by buying additional functionality for your machine. For example, if you watch me in my other videos, I have a single button that I press, it unlocks my spindle, I pull the tool out, I put a new one in, and it locks it back. That is called a power drawbar. That makes my tool changes be a couple seconds. Yes, I have to be there to do them, but they are only a couple seconds of effort. So most of my efficiency wastes are having to be there, but also, timing when I need to be there so the machine's not sitting idle waiting for me. But it's only a couple seconds of actual effort. So if this is something that's of interest to you and tool changes are going to be a loss of efficiency for you, when you're looking at machines, you should probably look at machines that have some sort of enhanced drawbar technology, be it power drawbar or a levered release, so that you can take advantage of that. Because otherwise you're going to have to be using wrenches to loosen up collets or tool holders every tool change. And that's now going to go from seconds to change a tool to minutes to change a tool. And God forbid you have to actually add a new tool to a collet, not some tool holder. Now you're going to have to actually index that tool off of your pieces and set the Z height as well, adding again minutes to your process. If efficiencies and bulk processing are important to you, that's another place you're going to want to find some way to have efficient and or automated tool changes, because there are automated ways to do it too. You've heard me say automatic tool changer. That's going to be a even more expensive thing than, say, a power drawbar. But that literally has the machine holding on to a set number of tools with numbers assigned to them. And so it'll just change the tool for you. And that obviously, as we've said, allows you to not even be there for the tool changes when they happen. There's a lot of different ways that you can hold down work and make jigs. This is just one example. But what I want you to walk away from this video with is, if you don't have a machine yet and you want to make money, you have to keep this sort of stuff in mind when you're evaluating the machine that you're going to get. If you're a hobbyist like me that just mostly does prototype work for fun, it matters a lot less. But if you're trying to make money, these are things you need to consider. And that also means the better you can get at designing plates that hold in tight areas as many things as possible, the closer you can get stuff together and fit on your table, the more efficient you're going to be. So this is an art form that you can get good at. There's a billion different ways to hold stuff down: vices, clamping, crazy expansion jigs. There's a parallel expanders. You can have walls that get pushed up against from one side with like a clamp on one. There's a million ways to do work holding. Getting creative and getting good at designing how to hold those things all close together is, like I said, an art form, and it's where you're going to make money. And then, of course, obviously the interchangeability of fixture plates, and being able to use them with a larger fixture plate like my Tosa Tools one is going to be part of that art form as well. And last but not least, I do want to give you a sort of dumber look at how you can increase efficiency without doing a plate like this. When I do the tops of these magwells, I am not using any fixture plate. When I first got my 770, my Tormach, using the standard table with the 3 slots, I could fit only 4-inch traditional vices. I could fit 2 of them side by side, but I could only fit 4 inches. So I could, if I wanted to, set that up and hold 2 of these blocks and mill them from the top. With the addition of my Tosa fixture plate, I have a lot more granularity on where I can clamp things down. So it actually now allows me to fit 6-inch vices instead, which I couldn't do before. They would have hit my column, but I can now. And why is that important? Because when I fit 2 6-inch vices, these aren't 3 inches. So I can fit 2 of them next to each other, and I can index off the sides of the vise as like kind of the same concept of indexing off of this side here. So as I change and cycle through iterations, all I have to do is butt the piece up against the edge of the vise on by both the left and the right, do it for 2 vices, and now I can run 4 of these for the top operation without any special work holding. Again, that's not the greatest use in the world, but it does show you that even simple work holding like a vise can be a force multiplier when you get creative and you have the setup that allows you to take advantage of that. Hopefully this was helpful.